Hello and welcome to another Portworx demo. My name is Bhavin Shah, and in this demonstration, we are going to talk about the latest feature in Portworx Enterprise 2.11, which is support for IPv6 only clusters. So Portworx, since its inception, has been supporting IPv4 based networking stack in your Kubernetes cluster. But as Kubernetes has evolved and added support for IPv6 only and IPv4, IPv6 dual stack clusters, we have seen organizations with the need to run Portworx and get the same level of enterprise Kubernetes storage capabilities on their IPv6 only clusters. So as part of this release, we are announcing and introducing the support for IPv6 only cluster. Just to note, this doesn't mean that you can deploy Portworx on a dual stack IPv4, IPv6 clusters. The Portworx can work on IPv6 only clusters. And there is no separate, there isn't any change in terms of the way you deploy Portworx on IPv6 only clusters. When you deploy Portworx and it sees that the networking stack that you have uses IPv6, it will automatically enable that feature and deploy Portworx, and all that communication will happen through IPv6 IPs rather than IPv4 IPs. There has been a lot of work done under the covers to make sure that all your commands, all your different Portworx components support IPv6, but from a customer perspective, from a user perspective, nothing should be different. Like, you should be able to use all the same capabilities like cloud snaps, like snapshots, like Portworx Autopilot with IPv6 only clusters. Advanced features like disaster recovery and data protection, though they are not present in the 2.11 release, that's something that we'll follow up in the future releases with. So let's see a Kubernetes cluster with IPv6 only enabled and see how Portworx runs on it. So as you can see, we have a simple virtual machine based Kubernetes cluster, which is using IPv6 only. You can see the internal IPs that it uses in the IPv6 format. And each of these VMs has local devices or local drives that Portworx uses to create that unified storage pool that can be used for provisioning read-write once and read-write many persistent volumes for your applications. So we have already deployed Portworx in this demonstration. So if you do a kubectl get STC or storage cluster in the kube system namespace, you can see that we have a name for our cluster, a UUID, status is online, and it's running the latest version, which is Portworx Enterprise 2.11.0. If we look at additional details, so if we do a kubectl get pods in the kube system namespace, and then specifically look at Portworx pods, and let's do O wide so we can look at their IPs. You can see that all the Portworx pods do have an IPv6 IP that they're using to communicate between each other. Let's look at a couple of additional things. Let's exec into one of those Portworx pods. So let's use kubectl exec. Let me copy the name of one of the pods, and then it's in the kube system namespace. And then we'll start an interactive bash session. If we do a opt pwx bin pixicuttle status command, you will see that you have a Portworx cluster that is fully operational. We have a license attached to it. The node that we logged into has an IPv6 address. It has those local drives that are used for different storage pools. And here you can get an overview of all the different nodes that contribute storage and participate in the Portworx storage cluster. So you can see we have all the different nodes that we looked at in kubectl get nodes, all of them participating and providing storage as well. If we look at additional things, so if we just do a pixicuttle cluster list, we can get a similar view into the nodes without the additional cluster level status. So we can see the names of the nodes, the IPs, the version of the kernel versions that we have running, the amount of memory and storage that's available. If we inspect one of those nodes, so let's just do a cluster inspect, and let's just copy the ID for one of those nodes. Here you can get additional details about the node itself. So here you can see that it's node 04. Management and data IPs are right now the same, like the same interface, so the same IP. The IPv6 addresses, it has those three volumes that are attached to it, which Portworx leverages to build that unified storage pool. So this is how it looks, how Portworx looks on an IPv6 only Kubernetes cluster. Let's perform a simple application deployment, simple Postgres deployment, and see this in action, right? Like the point I want to convey here is nothing changes from an operational perspective. It just uses a different networking stack. So let's do a we have a couple of YAML files for this demo. So let's look at the postgres-demo.yaml file, which deploys a couple of different persistent volumes for me. So since it's Postgres, we deploy a pgbench-data and a pgbench-state as the name of the persistent volume of 50 gigs and 1 gig in size respectively. So let's exit out of this and then apply that YAML file to create those persistent volumes. And then do a kubectl apply. The second file that we have is the actual Portworx Postgres pod. So let's do a vi into the Postgres app.yaml file. Here you can see we have a deployment object that's being created with a couple of container images. So one of the things to verify here is, does your IPv6-only cluster have access to public registries or repositories, right? If you don't, like there are organizations that will block that outbound traffic if it's on IPv6 versus IPv4. You might have to deploy a private registry, maybe something like a Harbor registry that's available to your cluster to pull images from. And that's the case for my cluster here as well. So as you can see, I have a local Harbor registry that I'm using to store my Postgres and pgbench images. So we looked at the Postgres container. This is the pgbench container, and it tries to connect to our Postgres pod using localhost and the port number, and it generates 40 gigs of data against a 50 gig persistent volume that we deployed. So now that we have looked at the YAML file, let's go ahead and apply it. So I can do a Postgres kubectl apply-f postgres app.yaml, and this basically deploys my pod. So it pulls down those images for Postgres and pgbench from my private repo, downloads it on the node, creates those containers, and then once both of those containers are up and running, it will show me that my pod is completely up and running as well. So while the pod is getting deployed, let's look at the first thing, right? Let's look at the persistent volumes. So as you can see, we have a couple of persistent volumes that we wanted in our YAML file. Capacity 50 gigs and 1 gig. It used a px-db as our storage class. So if we do a kubectl get sc, we can look at all the different storage classes that exist. There are a few ones that come by default with Portworx. If you're a Portworx user, you already know that, but you can also create these custom storage classes using Portworx as well. So our persistent volumes are looking good. Let's do a kubectl get pods and look at how our Postgres pod is doing. So let's see what's going on. So it goes through a couple of different attempts. It tries to pull the images. I can do a logs-f. Actually, let me do a describe. And then let's take the name of the pod. I have to tell it what to describe. So kubectl describe pods and the name of the pod. So as you can see, it went through a couple of attempts to download the image. Looks like both the images are now successfully deployed and our containers should be starting. So hopefully that error goes away. Okay, perfect. So as you can see, our Postgres pod with the Postgres and pgbench container is now up and running. Took a few seconds for it to completely realize and start communicating with the internal registry, but everything looks good. The point here that we are trying to make is it should be generating some IO against our Postgres pod. So let's clear the screen out. Let's look at kubectl logs-f, and then I believe, yeah, that's the name of our pod. And then let's look at the Postgres Postgres container first. So we do that. As you can see, it goes through the initial setup. Everything looks good. We can start using the service. It created a database instance. Okay, so the Postgres container is up and running. Next, let's look at our pgbench container and see how that fared. So as you can see, we wanted our pgbench container to start generating some data against our Postgres container, which it is. So this will keep going on till it hits that 40 gigs of random data being generated against our Postgres container. So we know our pods work perfectly. Just one more thing, let's exec into the Postgres pod. Let's exec into the Portworx pod and look at the volume utilization and the volume details from the Portworx container. So opt pwx bin pixicuttle, and then just do a volume list. This lists all the volumes that exist. As you can see, we have this particular volume here. So let's just do a kubectl, not kubectl, pixicuttle volume inspect command, then just provide that volume ID. And it should have some data written to it. So right now it's at 832 megabytes. So it's continuously writing data to our Postgres pod. As you can see, since the px-db storage class that Portworx was using has a couple of parameters specified. So IO profile of DB remote, namespace is default. The replication factor was set to 3, so REPL 3, and you can see where all the 3 replicas exist. So it's spread across our Kubernetes cluster. So even if one of the node goes down, a replica will be present on another node, and Postgres can just pick up and be online again and start performing those operations. So that's a quick demo of how to use Portworx in an IPv6 only Kubernetes clusters running on-prem, running on virtual machines with local drives attached. Until next time, thank you for watching.